What's up guys, this is Hands Up. Today I have something new for you. Today we're gonna see the automated irrigation device for your garden. So automated irrigation device is an arduino based microcontroller. So it has sensor and it has this display ways, and this is a perfect way to automate your garden. So we are going to see how we can do this all in one. So as we can see, let's get right into it. Irrigation device for your garden right here. Here we got the power button when we start our device. To start our device, that's what we can do. This is the push button. Here we have a speaker. This is a piezo speaker, which is an alarm. We're gonna use it an alarm. Here we got an LEDs, 4 LEDs basically. They are the notification LEDs. This is always on notifications, the device activities LED, and these are the level of moist LEDs. Right here we have a USB port we are going to use. This is used to program our microcontroller. So we can use this way to plug Arduino and to program our device. So we can put this right here and program Arduino. Here we have a power cable. So let's open device and see what's inside the device. So we can slide this one and open the device. As you can see, this is what the device looks like. Here we have two output cables. These are the cables to the sensor and to the pump we are going to control. And we have here another cable which goes to the power sources we are going to need for the Arduino and everything set up in here. So what do we have in here? There's three. So here we have the Arduino, and it's Atmel 323 microcontroller, Arduino based microcontroller. This is where we are going to write our program. Here we have a relay, 12-volt relay. We're going to need to control the pump using this relay. Getting closer, we have here a transistor. This is 800 milli. IC max is 800 milli ampere current, and here are the resistors for the LEDs, not too super. So we got here connections to the LEDs and to the ground. Finally, we have here, this is connected to the sensor directly, which is going right here to the sensor. So this goes to the sensor, and using voltage divider, that's what we are going to output the microcontroller. So we got here cables connected on from digital output is A3 to the A8. These are the output LEDs to the speaker, to the LEDs and other stuffs. Here we have a variable resistor, which is adjusted to the maximum. So we are going to control the pump's current, because we are going to use a direct electric from the laptop's charger, which is high current. So let's run it and see what happens. So here we have our sensor. This is our sensor, which is deep into the ground. So we are going to put this on the soil, and the reading goes to the Arduino microcontroller in here. So we have this one is plugged to the breadboard, these cables, and using voltage divider, you see the resistor in here. Using that, we can divide the voltage and see the output of this, and that's how we are going to sense. So it's basically two electrodes with this coil deep into the we attach it with the gypsum board. So if you want to see how I build my sensor, I can do another video. Please write in the comment. So let's run this device and see how it works. So what we basically have here is we have connected here to the power cable. As you can see, I'm using a charger to run the pump, and this 12 volt voltage divider to run the transistor, because the 5 volt won't turn on our transistor. So we got from here we have the sensor. Here we have a sensor connected to the control unit, and here we have also a wire going to the pump. Here we have the pump. This is 12 volt DC motor pump with 1 ampere current flow. So we have water here. So we have this device. We have this pipe in here. So this and this are going to the soil. So when the reading goes to the microcontroller reads the value. It has a program. We are going to need to program it using our PC. So when we power on, so when the moisture level is 0, we have analog input in here to the microcontroller. The microcontroller will divide the value and get as a voltage reading. After that reading, it's going to decide what to do and to run gives 5 volt output to the transistor in the base, and the base lets the flow of current of the 12 volt voltage divide the voltage adapter. So that flow will turn on the relay, and the relay will turn on the flow of current through the charger to the pump. That's how we're going to work. So let's try this and see what's going to happen. So we have already set up everything in here. So now we're going to power our Arduino. So as you can see, our sensor is dry, which means there is no moisture in it. So when we put it in a dry moisture, let's see if we put it, this is a dry soil. We have a dry soil in here. So we put our sensor like this. So yeah, it's probably because we have only small area. So this is in a dry soil. So when we power up Arduino, our pump should pump water. But the thing is here, since I am using small piece, I'm going to pump water to this bottle right here. So when I turn on, the LEDs will light up, and the pump should pump in here for 5 seconds. That's because how long I programmed it to pump. So it lights up. As you can see, it pumped, and since still it's moist, the soil is still moist, it's alarming because water is not available in the pump. That's what it's saying. So it will wait for 5 seconds again, and the pump will run again. The pump will run again. It goes like that. So it keeps alarming. But if we put the pump to here, it will stop pumping immediately. So let's try it with using the moist one again, and we'll try it what it does when it's moist. So I did it. I've done it. I made it in the moist soil. You see, this is a moist soil. So when I put my sensor in here, see, the soil is moist. So it says the green LED is bulbing, and the notification of the piezo is changed to high frequency alert. So which shows the moisture is full and is above what we need. So let's see again when the moisture is dry. We have our sensor in this dry soil in here. So our pump should pump right away. As you see, the pump has just pumped. This is a setup of automated irrigation device for your garden. You can control it, everything you want automatically. So first thing first, we have the sensor here in the moisture sensor. It's a moisture sensor dipped into the soil. So this gives the information to the microcontroller. So we have here a voltage divider. We're going to dividing. We have an analog input to the microcontroller, and the microcontroller is attached to the here the 2N222 transistor through the base, so it is controlled as a switch. So when the microcontroller gives feedback about the dryness of the soil, so this switch goes on, which allows the flow of current of the 12-volt adapter through this cable. So the flow of 12-volt allows the 12-volt relay to be on. So the 12-volt will be on in here. So the flow of the 12, when this goes, the coil energizes, there will be flow of current of the pump. So here we have 12-volt 2 ampere current DC pump valve. This is especially found in cars. So this is connected with the relay circuit, and the relay circuit will supply energizing coil, which will allow the flow of current. So here we have a USB cable port of the Arduino, which is going to be inserted, and now we are using it as a power, we have already programmed our Arduino. So let's try and plug it in. So you see, pump turns on because probably the moisture is gone. But since we didn't supply the water, because the pump is in other place, the alarm will turn on because there is no water supply given. So we have a speaker in here, piezo speaker, which will turn. And this is a notification LED. This is always on, and if the soil is still dry, notification. If the soil is moist, this will turn on. So this is how it works automatically. The link will be in description how the circuit is designed, and of course the program of the Arduino microcontroller will be still there. So this is because it's still, we are inserted in dry. If it was moist, it would have been, this will light on, and the frequency of this bit of the piezo will be a little bit different. So we can use, this is the pump has already pumped. It was pretty empty, but see what a mess I've done to my place. So see you next time with another setup. Peace.